Great. Okay, I think we're ready to go. So I'm David Hancock. I am the chair of Syria, non-exec chair of Syria, and also I am the construction director and infrastructure lead at the newly formed NISTA, which reports to Treasury and was a combination of the National Infrastructure Commission and what was the IPA. Thanks for joining us today. Hopefully you're all here for the Antarctic Infrastructure Modernisation Programme. And before we start, a few housekeeping. So the webinar is being recorded. All attendees are in listen-only mode. Raise your hand to indicate if there's something you need from the host, or you can't get in, or you're having problems, and I'm sure Charlotte will help you. So type any questions you have in the Q&A box, and if you see a question when you go in there that you like, if you can put a thumbs up on there, that'll give us an idea of what the popular questions are, and I can ask those questions. If you have a particular person that you want to answer the question, if you can put their name in as well, and then I'll direct it to that person. So just to give you a background for those who don't know who Syria are, Syria is obviously an industry research and information association, which is a not-for-profit member-based organisation. As it says on this slide, Syria works collaboratively to be the leading provider of knowledge aimed at improving performance in the UK's built environment and construction sector, and that Syria strives for continuous improvement. These are the Syria members. You can see there are more than 80 of them, and we're keen to get more people in. We're growing as much as we can, and the more people we get in, the better it is for us. The other part of Syria is Build Off-Site, set up in 2004. It's the voice of industry, really there to promote and support the increase and adoption of off-site and pre-manufactured solutions. And we'd like to be the trusted independent voice of the construction industry, especially with respect to off-site and pre-manufacturing, and looking at all the advantages that can give us in the industry. These are the Build Off-Site members. So today, hopefully you're all here for what I think is a really exciting programme, which is about the work that the British Antarctic Survey are doing in order to replace the old buildings that they used to have out in Antarctica, which are hopefully being replaced by more efficient, better environmentally, and also good for people to work out in the Antarctic. You will hear about the overview of the British Antarctic Survey and the Antarctic Infrastructure Programme. You'll hear from some great speakers all about design, the delivery of the projects, life on the station, and at the end, hopefully we'll have some time for some Q&A, and we'll do some closing remarks. Great lineup of speakers here, you can see, from all aspects of the programme. Ellen, who leads from BAS, Bruce from Rambold, BAM in UK, good representation, Robert and Scott there, and then Christopher also from Rambold. So I think we're going to have a really exciting programme. I don't want to steal Ellen's thunder by saying, but the AIMP project itself started in about 2019 for the building. I was lucky enough to go out there in 2018 in January, and then again last year went down on the Attenborough with Ellen, but I'm sure She can give you far more information into what the building is, why it's there, and the other development that's going on apart from the Discovery building. So Ellen is a font of all knowledge for the programme. So without any ado, I'd like to hand over to Ellen to give you the overview.
Thank you, David. Good morning, everyone, and thank you very much for this opportunity to share with you an overview of the British Antarctic Survey and our Antarctic Infrastructure Modernisation programme. But before we start, I'd like to put a quick poll out to you, asking what is the biggest challenge in Antarctic construction? Is it weather, logistics, or people? Please take the opportunity to vote, and we'll come back to that poll towards the end of my presentation. So hopefully we can get the slides are working, so that's always a good start. I'd like to kick off with a video about the British Antarctic Survey, just to give you a bit of a flavour of the work that we do before I go into a bit more detail around our mission and our strategy, and then the infrastructure modernisation programme that I'm currently leading. So hopefully that's given you a little bit of an insight into the British Antarctic Survey. And every time I watch the video, I get such a sense of pride around the work that the British Antarctic Survey is delivering. In terms of the British Antarctic Survey, our aim is to be the world-leading centre for polar science, addressing issues of global importance and helping society to adapt to a changing world. We do that in a number of ways in terms of our commitment to excellence in science, making sure that we operate in a professional and innovative way, and making sure that we're a partner of choice for delivering on our works. We're working in a very extreme environment, and it's important that we commit to the environmental stewardship of that region and making sure that we sustain our science to deliver and inform policymakers and the government. We're also responsible for sustaining an active and influential presence in Antarctica and playing a leading role in Antarctic affairs, particularly around the Antarctic Treaty. In terms of where we're based, we have 5 research stations in Antarctica, and we also have a station that is shared in the Arctic as well. These are based 2 on the continent, so that's Halley on the main part of the continent and Rothera Research Station on the peninsula. We then also have King Edward Point, Bird Island and Sydney within the sub-Antarctic region as well. And much of what we do is facilitated from either the Falkland Islands or South America. And as you can imagine, it's fairly challenging to get to some of our stations. So our operations are very complex. We have to navigate our way from the UK all the way down to Antarctica, whether that be through aircraft or with our ship. We also travel across the continent as well, and we will use tractor traverse and smaller twin otter aircraft in order to navigate our way across these operations. So as you can see, it's a very complex picture, but we are delivering incredible things as part of that. In support of delivering all of that, we've established a strategy. Our 10-year strategy was published in 2023, so we're just a couple of years into it. And you can see there our vision, our priorities for change, and what we will do to enable those priorities. And at the heart of this is one of our key priorities is around modernisation, making sure that we've got modern and future-proofed assets and infrastructure to enable us to deliver on our science and our commitments. And this forms the basis of the Antarctic Infrastructure Modernisation Programme. So what is it? It was commissioned by the Natural Environment Research Council as part of UKRI, and it's the largest government investment in UK polar infrastructure since the 1980s. And the aim is to make sure that we can maintain access and enable our capability to ensure we remain at the forefront of cutting-edge science and innovation in the polar regions. This is an essential part of making sure that we can continue to deliver on our commitments. And so far, we've had 2 phases authorised to date. The first phase was very much focused around our logistics and our capability, and in particular, our polar research vessel, the RRS Sir David Attenborough. This is a world-class polar research vessel that started its journey in 2014 and actually had its first Antarctic voyage in 2021. This vessel forms part of our logistics, but also our science capability. It will deliver our requirements to stations, but also it will undertake scientific cruises. And most recently, it's been doing this in the Antarctic and also the Arctic with some work around Greenland as well. We've also delivered a new wharf at King Edward Point, as well as rebuilt and extended the wharf at Rothera Research Station. This was to facilitate the ship so that it can arrive safely at our station and we can do our relief activities as part of that. Additionally, we've improved storage facilities and jetty arrangements at Bird Island Research Station. Unfortunately, due to the configuration of Bird Island, we're unable to take the ship directly to the station. So we will take a smaller tender across to the station with their supplies that they need. So again, the facilities were there to improve that capability and make sure that we can deliver and maintain each of our stations. The next part linked to logistics is the Discovery Building. This is our most recent project that we've been delivering at Rothera Research Station. It started in 2019, as David mentioned, and the commissioning and takeover of the building was in 2025. So earlier this year, we completed the commissioning of the electrical systems, the mechanical systems, the fuel, and making sure that that was all operating correctly, because that provides us with our life support systems on station. So that is what is keeping the station running and making sure that everybody is safe. The Discovery Building replaces 6 existing buildings, some of which have been there since Rothera was established back in 1975. So this year we are celebrating 50 years of science and research at Rothera, and the completion of the Discovery Building has coincided with that, and we're using that as the opportunity to look at how are we changing and how are we transforming the working and operations at Rothera as a result of the Discovery Building. So the operations that were in those individual buildings have been consolidated into one large building. That includes the vehicles workshop, offices, central stores, and also some recreation and training facilities as well. It's essential that we keep everybody up to date with the training requirements that they need to be safely operating on station. This will also form part of our new operation in terms of the aircraft. So at Rothera Research Station, and you can see a fantastic aerial view of the station here, we do have a runway adjacent to our main station, and you can see the Discovery building standing out quite resplendently there. The next phase of AIMP includes further work at Rothera, so there's very much a focus around this station. This is our primary station. It is also the hub for accessing the deep field as well. So many of our works and also other Antarctic programs, they will fly to Rothera and then they will fly onward into the continent in order to undertake their deep field research. So it's essential that we keep these services available, not only for us, but for others that are using it as well. One of the first projects as part of the phase 2 was to resurface the runway. So in a similar vein that motorways have to be resurfaced, we had to do the same for the runway. That's been in place since 1992 and hasn't had any substantial work since then. So over time, the surface has degraded, and we need to make sure that we actually repair that. So 2 years ago, we resurfaced the runway and made sure that's now available for ongoing operations, and it demonstrated a huge improvement in our ability to clear quickly in order to make that runway available for others. Additionally, you'll see we have a hangar for our aircraft. So BAS currently operates 5 aircraft, and we do undertake some light maintenance and works at Rothera itself. So we have a hangar there. Again, that is another part of phase 2, where we're looking at the redevelopment of that hangar. One of the key objectives around the phase 2 business case is around ensuring that our estate is in a suitable condition so that we can continue to operate it for many, many years to come. We've already done 50 years at Rothera. We want to do 50 and more beyond that. So we need to make sure that we've got the infrastructure there to support it. Another key objective of the business case is net zero. And we have a huge ambition to achieve net zero for all of our operations, but in particular in the Antarctic, where it is a particular challenge to achieve. You'll see here on the left, that is a map of Rothera, which shows all of the areas that are restricted where we can put renewable energy. So it's quite a constrained site. It is quite challenging to introduce it, but we've developed a roadmap with a hybrid solution in terms of the different types of energy that we can implement in order to try and move towards our ambition for net zero. We're also looking on the right at Sydney Station, and the intent is to redevelop that and introduce renewable energy there so that we move to be a zero emissions station in that location as well. So though it feels like the programme has been going on for quite some time, we've still got a lot more to go, and our current business case takes us through into the 2030s. In terms of the delivery model itself, so we can't do this alone. We need to make sure that we've got the right people supporting us and enabling us to deliver. And you'll see that there are many parties involved in this. We work in a collaborative partnership, and that's with many different organisations, not only our parent company, so the Natural Environment Research Council and UKRI, but also with government departments, the Foreign Commonwealth and Development Office, and the Falkland Islands Territory as well. Additionally, we have a partnership, and you'll hear more about that from the other speakers that have joined today. But BAM, Ramboll, Turner & Townsend, SWECO, Hugh Broughton Architects and NOR are all key partners in ensuring that we can deliver effectively in Antarctica. It's such an isolated location. We need to ensure that we're able to deliver in a partnered way, in an effective way, and making sure that we're delivering the best for what we need as part of our infrastructure. To support this, we've developed a charter, which is something that all of the partners sign up to in terms of the commitment that they provide to the organisation and the programme and what we are delivering as part of it. Our intent is that we will collaboratively deliver safe and sustainable infrastructure solutions which support our continued delivery of world-class science. In support of this, we've got many objectives around setting our standards for delivery, making sure we build the right thing the right way, improving sustainability, and enabling a positive impact as one team. This is a hugely important area that we're working in, and it's essential that we make sure that we build that in an effective way. And you'll hear a bit more about each of these areas through the other speakers during the course of this presentation. We also have some core values that we ensure that we embed within each of our respective organisations and when we're working together as well, making sure that we do collaborate and work as a team and appreciate and celebrate diversity. One of the things around working in Antarctica, there's never one solution, and you always have to find a way of working with things. We do not easily have access to extra materials or resources, so we need to think differently around how we approach the work that we do. And as part of that, we try and celebrate curiosity and challenge to make sure that actually we are pushing ourselves to be the best that we can, but continue to respect each other in the way that we work together. And ultimately, we want to take pride in our work. I feel hugely proud to be part of the British Antarctic Survey and also leading this programme. It is a huge investment, but it's also the opportunity to inspire the legacy of what our future will look like and making sure we can continue to deliver on the scientific commitments that we've made. So that concludes my overview of the British Antarctic Survey and the programme. Hopefully that's given you a bit of insight into the different areas that we want to cover, and others who have joined us in this webinar will also pick up on some of the areas that I've mentioned here. But before we finish, we'll just go back to the poll to talk about what is the biggest challenge in Antarctic construction. By a fair chunk, logistics has been identified, but again, weather and people are two particular factors. And during the course of the presentation, you'll hear more around each of those areas. But for now, I'll hand back to David.
Thanks, Ellen, and thanks for giving us a great rundown of the background. Can I remind people, if they have any questions, to put them in the Q&A, and if you have a particular person you want to direct it to add that too. Next, I'd like to introduce Bruce Wolfe, who's the Framework Director for Ramboll, and he'll be talking about the design and innovation and sustainability. Over to you, Bruce.
Thank you, David. Thank you, Ellen, and good morning, everyone. Gone one slide too far. Let me just go back. There we go. So my name's Bruce. I'm a project director with Ramboll. I have been working on the BAS framework for 10 years now. So my challenge today in 10 minutes was to try and squeeze 10 years into that. So I've just picked a couple of things that I think are hopefully interesting for you, but also very important when we're designing. And one of these things is innovation and modern methods of construction. As you can appreciate, that's even more important in Antarctica than other places. We have quite a short construction season. It's about 5 months each year where it's not too windy or dark, and you can safely get people off station if you need to. So anything that we can build off-site is an advantage. The nearest B&Q hardware store is over 1,000 miles away. So that's the equivalent of going from, say, London to Rome if you've forgotten a bag of nails or something. So an example of this was the new Rothera wharf. This was designed to be bigger and deeper than the existing wharf to accommodate the new RRS, Sir David Attenborough ship. And it was designed in such a way that it could be pre-assembled in large frames and then lowered into the sea, as you can see on the picture on the right. And this really sped up construction, allowing us to build it in just 2 seasons and demolish the old wharf, which obviously keeps costs down if you're having to fly less people out and accommodate them on station. And also in the harsh weather, in high winds and -degree temperatures, anything that you can build sort of in a more comfortable environment is a bonus. Another innovation was automation. So we use parametric models and computational algorithms when designing this beautiful new Discovery building. As with any building, there's so many parameters that go into the design, the orientation of the building, the weather, the solar gain, the thickness of insulation, the amount of occupation, how you're going to provide the energy. So what we wanted to do was to be able to work through those different parameters as quick as possible. So we set up this model where you could plug all these parameters in, and it would solve, millions and millions of different scenarios in just a few minutes. Something that would, normally take months if you're doing it manually. And then we could adjust the model very quickly as well. So, if the client wanted something that was, cost was the most important thing, or speed of construction, or quality, or embodied carbon, we could adjust those parameters to get the most optimized solution. And we also did that for the type of building and the type of materials and the construction method. So we set up another model. Was it going to be best to have a steel frame, or a modular, or timber frame? And again, we played around with the parameters as to what was most important for this particular building. This graph wasn't quite updated, but in the end, the chosen option was the steel frame. So the bar graph on the left there. So we must have tweaked it a bit again to not choose CLT, cross-laminated timber. And it all led to this lovely discovery building, complete with solar panels and combined heat and power, triple glazed windows, nice and thick insulation. We went for a light colored cladding just to help regulate those solar gains. And overall, this is leading to a 25% reduction in the amount of fuel the building used compared to the existing older 6 smaller buildings. Everything is powered by diesel out there, MGO, marine grade oil, whether it's your heating or producing, potable water. So it's really important to reduce that as much as possible. And we're on course for a BREEAM Outstanding as well, which we believe is the first on the continent. But we didn't want to just look at the embodied carbon and the building physics. As Ellen mentioned, that the whole ethos of BAS is, ensuring our planet is safe for future generations. What happens in Antarctica certainly doesn't stay there. It affects the rest of the planet, which is obviously undergoing significant change at the moment. As Ellen mentioned, one of those findings was the hole in the ozone layer, which was 40 years ago. So we really wanted the design to match that, and not just in the building, but the overall operations of the station. And one of these things was snow management. There we go. Next slide. So snow buildup is a big factor on these stations. It doesn't actually snow that much. It's quite a dry continent, but there's a lot of wind and there's a lot of snow lying around. So when it blows, the wind gets everywhere, it covers up all the buildings. And so the guys living and working on station have to spend a huge amount of time clearing snow away from doorways and windows, which obviously detracts from their main purpose of being there, which is to do this, all important world-leading science and research. Especially if this snow is, covering an escape route. So the next couple of pictures is taken at the same point, but different points of time, and you'll see how the snow very quickly builds up. Especially if you keep an eye on the bottom left building as we plunge into winter. Yeah, so you can see that building. If that's the accommodation block, it's not. But if it was, and you had to clear that each day from your window, it would be quite a arduous task. Especially if then blows a gale that night, and you have to press repeat on it. So we wanted to incorporate that into our design. How could we minimize this snow buildup, and what options did we have? So one option, a sort of very tried and tested classical method is orientating the long elevation. If you have a long, thin building, you orientate it along the predominant wind direction, and typically the snow will then hit the building, slow down, and you create a snow tail on the two short elevations. And you can design the building so that, you know, windows and doors aren't on those shorter elevations, and so it's not such a big deal if snow does build up against those. You can also put the building on stilts, which again, a few of the buildings at Rothera are, and that's also very effective. The snow blows under the building and deposits further away from it. Those stilts can be hydraulic. So this is another BAS station, Halley 6, and this one actually has hydraulic legs that can step itself out of the snow, and then you pack some more snow underneath, and it ensures that it always stays on top and doesn't eventually get lower and lower. And then there's also something called a wind deflector or snow deflector. So the theory behind this is that it blows the wind and snow over the top of the building, and then it's channeled down by this deflector in such a huge, you know, volume and force that it scours away from the side of the building and then deposits a few meters further away, you know, which is much easier to clear and doesn't block doorways. And that's the solution we went for on the Discovery building. The picture on the left is a physical test in a lab in Canada where we built a scale model of the whole station. It was a water flume where you poured sort of really fine sand in there, and we played around with all the parameters until, you know, the BAS end users were sort of saying, yeah, this is how the station actually behaves in real life. And then we could put this deflector along the long edge of the building and see how it worked. And it worked in the lab, so we thought, let's give it a go. And there you can see a picture from the previous season where they've started installing this huge structure. And it, you know, they do have them in some Nordic countries, you know, above doorways and things, but not on this scale. This was 90 meters long and really quite a big structure. So we're all quite nervous to see whether it would work or not. This is before the deflector was installed, so a season before. You can obviously see there's a big amount of snow buildup happening on the southern face there, and you're using big machinery to clear it away. But there's obviously the risk that the excavator will, you know, or the vehicles will damage the side of the facade, which is not what you want. So it's a time-consuming process to do the last few bits by hand. And you can see a guy there in the bottom left smiling as he's digging away the doorway. Probably not smiling after he's done it sort of 10 days in a row. So we did install the deflector last season, or the season just gone, and thankfully it worked. So there you can see it in action where it's scoured away the snow by and large and deposited it a few meters further south. So a big relief for the Ramble share price, and hopefully a precedent for possible future buildings as well to use a similar system. That's all from me, so I'll hand back to David for the next speaker.
Thank you, Bruce, and that's really interesting, and shows you some of the work that was done in models before you took it out to Antarctica. Our next speakers are Robert Kerr and Scott McLean, who will talk about some of the digital aspects of this. Remind you again, if you can put in the questions in the Q&A, we've got a few in there already, but if people have got that. So hand over to Robert and Scott.
Good morning all. Thanks, Dave. As Dave says, my name's Robert Kerr. I'm the senior agent responsible for the delivery of the Discovery Building project. I've worked on the British Antarctic Survey Infrastructure Modernisation programme for approximately 6 years. I joined originally as a planner and then moved into a role in on-site delivery. And I've been lucky enough to deploy into Rothera three summer seasons and oversee the safe and successful delivery of the Discovery building, as Ellen and Bruce have touched on. My colleague Scott will touch on some of the digital aspects that we've taken on the Discovery building and previous projects, and I'll allow him to introduce himself and give himself a bit of a background when we come to his slides. So obviously construction in the polar environment is extreme. There's many facets to it. Purpose of the slides that we'll go through is just to give you a bit of it's going to be a bit of a light touch, similar to Bruce, to try and squeeze 6 years of work into 20 minutes is going to be a hard shift. So I'll touch on just the foundations of what we feel are the foundations to successful construction in the polar environment, the key principles we adopt and live by, and empower our team to deliver to. Scott will touch on some digital construction aspects and how we've utilised some exciting tools to our benefit to secure delivery. And I'll touch on some of the project-specific challenges, more unique ones to the Antarctic environment. And I'll touch on a couple of the projects that we've completed to date and some of the challenges we've overcome there, time permitting. So in terms of the foundations to success, so there's many models for delivery of a construction project, but as an organisation at the outset, we embraced Project 13's pillars, 5 pillars of success, and ICE systems approach to infrastructure delivery. This essentially is ensured success through collaboration, front-end thinking, information sharing, information management, and digitisation, all with an eye on the end, the outcome, to ensure that projects are shovel-worthy when it comes to the execution phase and sustainably delivered. I would say working together, and Ellen's touched on it, we're all as a partnership, one team, but working together is the golden thread to success. And I think it was typified by a decision early in our partnership to get together as a partnership and co-locate into the BAS Cambridge office in Cambridge. That got all partners under one roof working together and understanding how BAS live and operate in Antarctica. As Ellen's touched on, the most important thing is that BAS continue to be able to deliver their science, and construction doesn't impact that, but only benefits it both in the long term but also in the short term. So I can't undervalue how important it was that we co-located and under the one roof. It allowed us to learn the lessons from years of polar operations that BAS have delivered. So understanding the challenges around logistics, how we operate and maintain plant in the Antarctic environment, resource selection considerations, looking at PPE, pre-deployment operations, understanding how they operate on site in order to ensure that our designs are designed in such a way that the construction phase deconflicts and doesn't impact the actual continuation of polar science research. So as Ellen has also touched on, the partnership's made up of many cogs. As a contractor, our contracts with BAS, we value that, and we look to filter down those values, behaviours, and the contract mechanisms through our supply chain. It's a very balanced approach, and a steer away from the transactional typical type of contract that you would have, which is understandable given the environment that we're working in. but we believe in a filter down approach, and that's how we engage with our supply chain. The key principles of polar construction, as I've said, as an engineer, there's an old adage, proper planning prevents poor performance, and that certainly hasn't been lost on me. Less so on this job, I would say. It's critically important, I would say. The principles that we see here: build it before we build it. So that's about undertaking virtual trials, test builds, extensive FAT testing, to ensure that once we get to site, things are deliverable. Practical, repeatable, predictable. That's all about modular construction, making sure that we utilise similar material types, construction methods are repeatable. Again, all building towards efficiency, either in material selection, plant that you can use, or just gaining efficiency through the repeat cycles. Early engagement, similar to what I touched on earlier, we're involved in an ECI with BAS prior to deploying to site to deliver construction. As part of that ECI, it encourages early contractor involvement, so getting people in at the front end, allowing us to understand and shape scope so that projects are deliverable and on budget. Right first time, and I'll touch on it later, a couple of the challenges is the constrained construction window. So it's essential that we get things right first time. There is a limited construction window, and just from a sustainability perspective as well, we don't want to be doing rework, but certainly the constraints make it ever more important. Start with the end in mind, so that's understanding what the outcome needs to be. So ensuring that we have defined requirements, we understand what the client needs. That allows us to shape the scope, the design, and the delivery, and ultimately end at the right outcome for everybody. And digital is the new norm. So digitization, I'm not going to steal Scott's thunder. He's got a lot of good points that he's going to run through, and I think that's a nice bridge into Scott's presentation, and I'll hand over to Scott so that he can run through how we've used some of the latest digital tools to our benefit, to ensure successful delivery and execution. Thanks. Cheers, Scott.
Yeah. Thanks, Robert. So I'm Scott McLean. I'm a senior digital project lead for BAM. I've joined this project in April 2018, and I was lucky enough to be the site engineer in 2019 for the groundworks for the new Discovery building. I then came back, COVID hit, and I made a sidestep into digital to remain on the project. As it is, it's a wonderful project to be a part of, and the challenges are unmatched, I would say, especially you just don't get the same environment and the team elsewhere. So part of my role is to really start to look at how we utilise the information that we are provided. And as Bruce mentioned, we're 1,000 miles away from the nearest B&Q. We're also 1,000 miles away from the nearest hospital, and that's also assuming that the weather's good enough to fly. So one of the main things that we use the models for is communication. The image on the screen is what we've done to complement activity plans and risk assessments on site. Make sure that the labourers are aware of the process. They've got a better understanding. It's not just reading a lot of words or being read a lot of words. They can look, they can get an understanding, they ask good questions. We'll leverage the two-dimensional and the three-dimensional together to make sure that what we are trying to put across is the information and everyone is aware of what we are trying to achieve. That also works as well when communicating with BAS. in terms of we're working with scientists and people who may not fully have the same appreciation to understand detailed drawings the same way as engineers do. So the 3D model gives them that access to really understand how multiple disciplines interact. It means we can go to the end users and really give them a walk around of what that end product, what they're going to get, is going to look like. And we do find it flags up a lot more end user issues and gives them their say in how they would want things to be over the drawings. They do get the drawings, but as always, it's difficult to compare when you're looking at 3 or 4 different disciplines or mechanical systems. So that also takes me into the model coordination area, where for the discovery building, we've had over 60 supplier models all federated together. That makes it really complex, and that's where clash detection and where getting it right first time really comes into. Being able to do this before we get to site, being able to identify the issues mean that we can prepare for anything that we might face on site, or, as is always the priority, if we can design out those issues. It gives us a lot better starting point for the season, and it means if we are aware, we can mitigate around those issues. As for if we find out the issues, again, as Bruce said, we may not have the tools to deal with that. It may impact the season. We may not have the right people there at the right time. So it's to give us the best start and the best chance to make a successful season. It's worked really well, and there's lots of different things. So you can see on the screen the sheer amount of clashes that we've had to deal with as we go. And we do update it with the as-built information as well, to keep it live and keep it active, so that we're always looking to see what's happening next season. Moving on, the model coordination also gives us the confidence in design. So our supply chain, Jay Barney's, could use the design. They were confident that it all fitted, and that let us prefabricate over 80% of the MEP. So we used the design, they prefabricated it, ship it all down in containers, and then we'll see how it looks when it's actually on site and installed in the next image. So you can see just how much prefabrication has went ahead, but the prefabrication has meant that we can do it in a controlled environment in the UK, do the tests that we need to do, and cut back on 1, labour required in Rothera, and 2, it's really brought the programme to an achievable level as well as reducing the standard risks in installing MEP. And finally, the last wee bit I'd like to talk about is the validation of construction. So I've mentioned that we use the as-builts to put into the model coordination, and Robert will talk about the process that we go through each on-season and off-season. So we want to make sure that at the end of each season, we know exactly what's built. We do have sometimes problems with engineers leave or for whatever reason can't go back the next season. So we need to make sure we know exactly what's down there. We've recorded all the issues, we know what's been built, we feed that into the model, and we progress with the information. And we use a laser scanner to capture the as-built. We've got 360 images. We've got very good insight into what's down there without needing to go down there, which gives us, again, that chance to prepare properly for the next season and get it right first time. So thank you, and if there's any questions, then I'll be happy to answer at the end.
Thanks, Scott. Appreciate that. So the next couple of slides, what I'll go through is some of the more unique project challenges that we have to deal with when delivering works in and around Antarctica. Obviously, all projects come with their challenges, but to cover them all would take certainly a lot longer than I've got. So I'll just focus on the ones that are specific to Antarctica. So in terms, I touched on it earlier on, a rather obvious one is that our construction season is constrained by the weather and the seasons. So typically the austral summer, working summer, will span from the beginning of November through till the end of May, or sorry, the end of April, beginning of May. And that is actually an extension on what BAS have typically done previously. So their flying season will end around about the middle of March. So construction as it is has actually resulted in an extension in the summer season in Rothera in order to make the programs work. So typically we would fly in the beginning of November and there'll be approximately weather, depending on what the winter's been like. If there's been a particularly harsh winter, it'll be typically a month of snow clearing and site remobilisation. So getting walkways up, making the site safe, putting traffic management processes in place so that we can manage people working in and around the construction site. That'll lead in concurrent to an approximate 4 to 5 month construction window, weather permitting, and leaves us with approximately a month to, or 2 weeks to a month to undertake some winterization prior to leaving site at the end of April. And by leave site, it's not just a case of shut the gate, lock the gate and walk away. There's a lot that goes into it in terms of preparing plant, so that it's left safe and you're going to come to it and it's going to be in a workable condition. So we have to winterize all our equipment, we have to winterize site. So if the permanent works are being left in a partially constructed state, we need to ensure that those are going to be safe throughout the harsh Antarctic winter, but also that when we come to it, we can actually get back into it. So we need to flag things and make them visible. BAS typically operate the station during the winter, albeit it's a skeleton team of about 20 to 30 people. But we also need to make it safe so that they can operate and they don't carry a residual risk through their own winters. So there's a lot of thought goes into the seasonal approach. Out of construction, i.e. we call it in the off season, between June and October, typically our staff will be having a well-earned break because they spent the best part of 6 months south. And then they will go into a phase of design, finalising designs, procurement and preparing logistics for heading south. I'll not dwell on the travel south too much. Ellen touched on it. Typically there's 2 routes into Rothera, one via Chile in South America, Punta Arenas, and via the Falkland Islands. Those, if you're flying using the BAS aircraft, which is the bottom right-hand image on the screen as you see it, it would typically take around about 3 days, all going well, weather permitting. But you could also get the Sir David Attenborough in, which is the top image, or another vessel, and that would typically take about 7 days. So it's not your usual commute to work. In terms of one of the challenges that you I think these are earmarked as the highest challenge, is logistics. So yeah, typically, as Scott and Bruce have mentioned, the hardware store isn't around the corner. So we typically have to spend an awful lot of time up front identifying down to the nut, bolt, what equipment we need, screws, drill bits, etc., in order to deliver the works. In seasons, we have a small opportunity to get material south using the Sir David Attenborough. BAS typically allow us to put a couple of containers on that, but touching on what I said earlier about not impacting polar research, that the key purpose of the Sir David Attenborough is to is to undertake scientific work on its journey. So we don't want to use that space up. So we need to ship the materials in commercially using commercial vessels. For the Discovery building alone, we've had 2, and these are F-type vessels to carry about 16,000 metric tons of material, and we have circa 400 containers in Rothera currently, which thankfully now are largely void of material as it's been installed. But we have an action this coming construction season to deconstruct the existing facilities, segregate them and pack them into the empty containers and ship them all north as part of a demobilisation vessel in March 26. So all exciting. Other challenges, environmental challenges to consider are weather. So it can be inclement at times. I would say that generally through the good parts of the season, December, January and most of February, it's not too different to a Scottish summer. Sorry, a Scottish winter. I wish it was like a Scottish summer. So the conditions are fairly workable, but it can change quite rapidly, and when it does, it does blow in, particularly the wind. The shoulder seasons are a lot more inclement and unpredictable, but typically we've been able to, as I said, work up till the end of April and begin at the beginning of November without significant challenge. Other environmental challenges are the wildlife, just sort of so that we don't have an impact on them. So deconflicting our operations, making sure sites are safe so that the wildlife doesn't wander into it. Penguins can be incredibly inquisitive critters at the best of times. Sea conditions, particularly for the wharf, and when we're looking at vessels, backloading and stuff like that, we need to consider sea ice conditions. And daylight can be an effect as well. So during the height of the season, we'll have 24-hour daylight. But again, that wanes off towards the end of the season. So we need to consider that, and particularly the effect it has on people's mental health and well-being, because working in an environment where you've got 24-hour daylight, it's different, and it's certainly something that we focus on in a pre-deployment training. Ellen touched on it earlier on that the Rothera is basically a logistics hub. It has an airfield right slap bang in the middle of it, and it's important to BAS to be able to continue their polar research using that airfield, but it's equally important to BAS and all their respective the other polar nations that use Rothera as a launch pad for getting into the deep field. So I touched on it earlier on about making sure that our operations deconflict with BAS operations as usual, and that's a big focus and can be sometimes quite a challenge. The last item I wanted to discuss was just in terms of resourcing and taking people south. So obviously, as I said, it's not your normal job. People come to the job and go home at the end of the day. In the UK, it's a much bigger challenge here. So in terms of construction, we generally have earmarked about 40 to 50 beds on a station that's about 160. That represents a 25% percentage of beds in Rothera. Ultimately, that changes the culture and the dynamic on site quite a lot, and that's something that we bear in mind and ensuring that we don't affect BAS operations as usual. It's important to consider the behaviours of people within work and out with work, the resilience to work in the environment, particularly for periods of time that could be in excess of 5 months typically. But we have had people that have wintered there for 18 months. So these are all things that we need to bear in mind when considering our resources. The resources are obviously capped at typically 50. This can result in challenges when we are slightly delayed, and it can result in challenges if we need to try and accelerate. So because of the fixed constraints in terms of the construction season, it's really important that we consider this, and we have a dynamic programme. We look at utilising multi-skilled trades and train those people to undertake specialist trades, so that we're not overutilising the limited bed spaces that we have and BAS have, and so they continue their polar science. So I think I'll wrap it up here. In terms of all of this wrapped up, makes finding the right person really difficult. One, they need to be technically right for the job. Two, they have to have the right values and behaviours, and have to medically clear them. And we're all working within a budget which is really competitive given the current UK market. So it's a fair challenge, I would say. Moving on to the next slide, I will quickly go through the current. These are the current projects that we've completed to date. So Rothera Wharf, King Edward Point Wharf, and Rothera Modernisation. I think if I was to pick one of those, it would definitely be Rothera Modernisation, because I led it, but it was effectively a heart transplant in the middle of an operational station, and that's no mean feat, trying to keep the existing operations ongoing whilst completing a really, really complex programme of works. And I'll apologise because I've ran over, and I'll hand over to Dave. Thanks very much.
Thanks, Robert and Scott. And don't worry about it, Robert. There's an awful lot that you covered in there, and I'm sure there'll be lots of questions around that. And great to see what's going on and what it's actually like to be out there as a contractor. So we'll finish off with, last but not least, is Christopher. Christopher again from Ramboll. Christopher, I'll hand over to you for the last presentation.
Thank you, David. So I'm going to move fairly quickly as we've only got about 6 minutes left, and I'm going to start with a video. So let's see if this plays. Hello there, my name is Christopher Lloyd. I'm a project manager at Ramboll, and right now I'm the site supervisor for the new wharf and science building in Rothera in Antarctica.
Hello, I'm Natalie Wathen. I am the framework manager for the BAST framework within Ramboll.
Hi everyone, my name is Helena Turner and I am a project director.
Just watching some of the cargo handling at KEP here.
What I love most working on this framework is the diverse people that I work with and such a huge number of people involved.
So I love working on BAST for two reasons. Firstly, my project is very cool. It's very technically challenging in terms of trying to figure out how to land a plane on the Antarctic. And also just everything about BAST and what they represent. They're on a mission to drive forward polar science, which is so cool, and it's just so much bigger than just a single project, and I love being a part of that.
Saturday, 1st of April, about 9 o'clock in the morning. Winds here are currently about 25 knots, gusting up to 30. As you can see, not much work outside really happening, but I'm giving it a shot all the same.
Yeah. So we're still doing the cargo unloading. At the minute we've got lots of frozen food, lots of timber.
Hi everybody, I'm inside now, I'm in the comms tower. Let's see if I can give you a little view outside. Satellite services behind me, roof of the Discovery building, and then the rest of the station behind.
There we go. Hope you can all hear that. Some good examples of the different environments that people encounter. A lot of the slides that you've seen have got these beautiful blue skies when everyone's standing outside the Discovery building, or you've got pictures of the runway or whatever. It really isn't always like that. In fact, those pictures are so good because they're the only days that they can take the photo. If they were trying to do the same thing on some of the snowy days, you just get a blank white screen for the most part. So there was a survey at the beginning of the presentation about what are the most challenging factors, or what do you think are the most challenging factors? We probably should have had information in there, because yes, logistics are a challenge, and yes, weather is a challenge, and yes, and I'll come on to it, finding the right people is a challenge, but information is a challenge as well. Interestingly, the weather and the environment are relatively unchanging, although they do, it does change, and climate change is having an effect on the things that we do. Broadly speaking, BAS has really good records of what the weather is like in Antarctica. This graph on the screen is something I came up with when we were looking at when was the best time to resurface the Rothera runway. So I was looking at what is the temperature, the average temperature for a week. So if you imagine the weeks are listed on the x-axis there. So week 1 being the first week in January, going through to week 22, I think, is May. And you can imagine that I was seeing what is the temperature for the week on average. And during this period, just after Christmas, week 52, 53 to about week 8 or 9, it's consistently just above freezing. But then after that, then it generally goes down, and it could be all over the place. You get colder years and warmer years, but generally after about week 9 or 10, you don't want to be doing work outside on the runway, because you're going to be dealing with these freezing conditions. So that's quite well known, and BAS is tracking the changes in temperature, in weather, in rainfall or snowfall, and more information is available every year. But let's talk about the people. Robert has talked a little bit about the people, and it's very easy to think of construction in terms of materials or technology, but all of this cannot be done without people. In the winter, BAS has a winter team. So that's our summer in the UK from May through to November. There's only 20 to 25 people on the station. So you've got your station leader, and there'll be a doctor, there'll be some scientists, there'll be various technicians to keep the buildings working. So electrician, a mechanic, a vehicles mechanic, maybe a plumber. There'll be diving officers and boating officers, or one of each, to run boating and diving. And there'll be a chef, there'll be field guides and assistants, someone to specialize in IT and communications, and probably a meteorologist as well. But it's not a very large group of people. It is interesting how few scientists are there on that list. It takes a huge amount of people, both in Antarctica and in the BAS offices in Cambridge, to support science. So, if you can imagine that, yes, you could have 6 scientists living in Rothera, but they've got to cook for themselves. They've got to look after the equipment. They've got to make sure the generators are running. So we have people who are set aside to that to support science. In the summer, Rothera goes up to about 150 people. So in November, new people start arriving. We have the pilots for all the aircraft, the aircraft mechanics. There's a traffic control team who run the tower. There are more scientists, but then to support them, there are more field guides, more chefs, more logistics personnel. And in the context of what we're talking about, up to 50 construction personnel and some additional people to support them. So people who are running the construction from the client side, so to speak, as a BAS construction representative. And that's a lot. When you're talking about the proportion of the culture, as Robert said, 50 out of 150 is a big proportion. When we look at people to go on deployment, we start looking as early as June. So June, July, we start looking for people, maybe doing interviews. And then into September, they're doing pre-deployment training. And the first deployments will be in November. They'll be working through December, January, and you'll have some late deployment people. Probably everyone who's going to go to Rothera will go there by February. And then in March, we'll start to demob people from the site. And then if there's anybody wintering, that's the last chance for them to come in March. So a lot of thought goes into finding the right kind of people who are going to be working on these construction projects. It's a big day. It's a long day in Rothera. Construction typically starts with a meeting every single day at 7 o'clock. So the entire construction team, 50 people plus supporting people, will be there at 7 o'clock every morning. They'll be typically working essentially a 12-hour shift. So they'll be working in all weathers, and you've seen some of the different kinds of weather. But even when they finish, they're still living together. The station is not that big. Everybody is in shared accommodation. So in addition to working together, people are living together, having their meals together, watching television, playing cards together at the end of the day. So there is all that. And the team does celebrate milestones together. The success of the Discovery Building, and I think this photo was taken when they finally put the tower on, could not have been done without the people that we recruited for it. And it is important that people have the right attitude and the right preparation for that. What are we looking for? Well, people essentially who are resilient. You have to be mentally prepared for the, it's not isolation. People talk about isolation in Antarctica. Yes, you're very far from home. You're very far from the UK. You're very far from your family. But you are also there with 49 other people that you can't get too very far away from. So you have to be resilient to the environment, and you have to be resilient to the social pressures and the social interaction that's down there. People need to be resilient, but they also need to be committed and cooperative, and be able to communicate with each other and get along with each other. And that's really important. So it's now 12:15, so I'm going to finish there and hand back. Hopefully there's some questions from you all, and if you are interested, there'll be some details and some contact links at the end. Thanks, everybody.
Thanks, Chris. Thanks for wrapping that up. As we said, we've got about 15 minutes for questions. So I'll go directly into the Q&A box. And the first one's, if people can put their Ellen, and everybody can come back online. Chris, thanks. So the first question's a nice easy one, which is, why have you got a green room, Ellen? There's a bright green room. What is the bright green room?
So the bright green room is the T point. So within the building, we've got a horseshoe arrangement with all the new offices, and in the middle there is a T point which we have painted green. Throughout the whole building, there are some very bright colours, which is developed as part of the design by the architects, thinking about how do those colours impact people when they're in that environment. So we've also got a good splash of red and a good splash of yellow through the building as well.
Thanks, Ellen. Next question here, which is kind of, it says, why a flat roof? But I think, Robert, you talked about the deflector. It's not quite flat, is it? It looks big and flat, but it isn't quite flat, is it?
I don't know if Bruce is better for answering this, but no, it definitely isn't flat. It's got roughly a 5 to 10 degree pitch on it. I'm assuming that the pitch on it is designed in such a way to harness the energy of the wind and ensure that it doesn't deflect too far over the side of the building. So it has to be flat enough to make sure that the wind deflector operates efficiently, but not too flat that it then becomes a pond, so to speak.
Anybody else, Ellen? Anybody in the design or?
No, that's spot on, Robert. It was getting that happy balance for the design. You still want snow and rain to fall off it.
Thank you. Next question. How are you going to ensure the future maintenance of the building when everybody goes back home? I suppose Ellen to start with, but anybody else?
Yeah, so Rothera is staffed all year round. We have an estates maintenance team that take on responsibility for all the existing buildings. They will take on the responsibility for the Discovery building. They have started that already, and part of our work to transition that into use is about making sure they've got all the O&M manuals, they've got the health and safety file with all the residual risks identified, and they've got a clear maintenance plan and job plans to go with each asset. The number of assets in the Discovery building is quite mind-blowing when you actually go through the whole list. So the BAM team have been working exceptionally hard with their suppliers as well to make sure we've got everything identified, so we know what we've got, where it is, what activities we're undertaking against it in terms of maintenance, and then also linking into our system where we can actually order new parts as well. So we've got a new system now that links everything up in terms of that logistics and making sure that we know whether we've got one in store or whether we've got to make sure that we've ordered it for next time we've got a shipment coming in.
And is that a BAS team or is that a BAM team? How does that work?
It's a BAS team, but over this winter, which is our first winter, we have 2 individuals from G&A Barney, who are one of BAM's subcontractors. They are supporting us with some of those maintenance activities as well. So we've got some good support there, but it will be predominantly a BAS team going forward.
Thanks. Another question, where in the UK was the M&E build undertaken?
The build, so in terms of the prefabrication, was undertaken in Inverness, in the workshops of G&A Barney's, who were our M&E contractor in delivery. So generally it was done there. There was a couple of other extensive FATs carried out at specialist suppliers. Again, rooted in Scotland mostly, I would say.
Thank you. I'm going to join 2 questions here. I've got one about what types of renewable energy you're using. And then there's another one talking about the eVinci nuclear reactor. And I'm sure, Ellen, there's probably some restrictions on nuclear in Antarctica, although I know the Americans back in the 1960s had a nuclear reactor. But what type of renewables are you using out there and that might even go to some of the Ramboll guys.
So currently, you can see on the Discovery building, we've implemented some solar PV, and that's the majority of work that we've done so far in terms of renewable energy at Rothera. We have got some work coming up to put more solar panels on the existing buildings, not the one to be demolished, the ones that are staying. And we are also looking at battery storage systems associated with those. We are also looking at the possibility of wind and also air source heat pumps at the station. We do have to consider things such as the bird population, which limits where we can potentially locate some of our wind turbines. As far as I'm aware, we haven't explored the nuclear option yet, but it's certainly one that comes up fairly regularly, particularly at COMNAP, which is the community of managers for National Antarctic Programmes, as an area that people want to explore further. So useful to get some information around what that looks like at the minute. There certainly was one previously on the American station, and there isn't anything deployed at the minute. And it would be an interesting discussion at the treaty meeting, I think, if we wanted to implement nuclear. But we also have to consider that it's very difficult to achieve it in Antarctica, so we've got to explore all options that are available to us.
Thanks, Ellen.
Just to add to that, it's as Ellen said, we're exploring all the different types of possible renewables from a design perspective and ruling some out. It's always a double-edged sword with innovation in Antarctica. You want to be, using the most innovative and up-to-date technology, but equally you don't want to use such a complex system that needs, a couple of technicians each season going down, who are trained in high voltage or whatever it might be, which would then be taking valuable bed spaces away from the scientists. So you want kind of simple, tried and tested systems that you can fix with a hammer and a bit of tape, but you still want to be groundbreaking as well. So we're trying to get that balance.
Thank you. Hopefully that answers your questions. It's one directly for Scott, and this is on the cost for BIM work. What do you believe would be the percentage cost increase required to take BIM information to this level of detail compared to the current approach for BIM for complex buildings built in the UK?
Yeah, I don't know what I've done to deserve that question, but I'll answer it as best as I can. The work that we do on BAS should be no different to what we do in the UK in terms of a complex build. So we use the same standards. We're working to the REBA 2020 stages, we're working to BG6, we're working to BS 8536, and most importantly, ISO 19650. So if we do it correctly, and from the very start, work stage 0, the strategic definition, and we build as we go through each work stage, and it's part of the project 13 with the ICE as well, working as a partnership. So we've got BAM coming in at early contractor stage to work with Ramboll to get the best design at the early work stages, to bring JMA Barney's in, to bring the suppliers in, to make sure that we're succeeding early on. It's very difficult to give a percentage increase when you do look at the benefits and the savings that brings. For Rothera Wharf, we saved over 2 million, I believe, in utilising the digital benefits. Discovery buildings slightly more, because it is a slightly more. So return on investment in BIM, we can be looking at up to 10% in some instances. So I wouldn't say that there's an additional cost. I would always be looking at the benefit and the outcome that following the BIM processes and information management provides.
Thank you. Next one here, and this is, I guess, for Robert. It says, out of all those workers, you've got 50 construction workers, how many of the BAM workers on average per season do you take down for the wharf originally, and then for the Discovery building? And then I believe, Ellen, that you've got to start taking the buildings down. So there'll be, I presume BAM will be around for taking it down as well. So either Robert or Ellen, what are the resources from BAM?
Yeah, that's fine. So for the wharf, that was all self-delivered. There was very little subcontractors on that. I would say that I think the resources for that project were somewhere between 50 and 60 on that, staff and labour, a mix of skills. On the discovery, to begin with, when it was the civils elements, again, it would have been up around the same level. But on discovery, it's typically probably around about 25 to 30 BAM, and the extra over would be covered by, be it a specialist M&E subcontractor, steel erectors or cladders, fire stoppers, and all that sort of stuff. So, and for completing the deconstruction next year, it's pretty much all BAM. We've got a skeleton squad of M&E coming in to do some minor snags, to deal with minor snags on the discovery building, but approximately 35 will be BAM operatives. So.
Ellen, anything you want to add?
No, I think Robert's covered it there. We've got good representation from BAM, and bringing in the specialist contractors where they need to is balanced really well.
And you've got other places, haven't you? We've talked about Discovery and Rothera because it's the big exciting one, but there is other things going on around the Baz estate, aren't there, out in Antarctica?
Yeah, there's always something going on. Even at Rothera, the estates team are still doing some other works as well. We've also been introducing renewable energy at Bird Island. So our estates team has recently delivered that. And during the summer, when the weather is a bit more favourable, they have managed to achieve net zero for a period of time using solar panels that they've introduced at Bird Island as well. We're also looking at Sydney, as I mentioned earlier, to redevelop that station, and similarly look to how can we get the benefit of net zero, and also take the learning from everything that we've done so far. We've done such a lot already. How do we then learn and implement that when we've done all these assessments around the different options for renewable energy? And where do we make the most of that, and then hopefully get a bit more momentum behind the work that we're doing?
Thank you. And a question to all of you: how important do you think it is to have been in Antarctica in order to be able to deliver a project like the Discovery Building in Rothera? Let me start at the other end. Let's start with Bruce. Is it important to get out there?
Yeah, 100%. It's such a shame that it takes so long, and it's such a unique, it would be great to send the whole design team there. To try and design something without, being there is obviously hard. No matter how many videos and pictures you've seen, you need to really go there and talk to the people and experience, the challenges firsthand. Chris, I don't know if you've got anything to add. How many times have you been now?
So I've been 3 times now. I have a little pet hate, by the way. I really hate the term BIM, because it's not BIM. It should just be IM. The building bit is really superfluous. It's not just about the building information management. This is something that's been happening on ships, for example, for a very, very long time. In this, you need to know what your inventory is for supplies, for spare parts, for fuel, for everything. And ships traveling around the world don't know where they're going to stop next necessarily. So they've been doing it in that way. But it's really important in Antarctica that we know what the building is doing in real time, but also what we need to do to maintain it, fix it, add to it later on. So, yes, I just don't think it should be called BIM.
And within that, I mean, is there anything that you've taken back to Rambo after that you've learned from Antarctica that you've taken back into your work, the work that you're doing not in Antarctica, Chris?
I think that when COVID happened, for example, and we all started working remotely, that kind of accelerated some of the lessons that we were learning with BAS, in that you can't always be sitting around the table with the people that you're working with. the people in BAS have been working remotely with their colleagues in Antarctica for the last 30 years in the case of Rothera. So it's not new to them. So this the idea of information management and finding different ways to communicate and making sure that every database and list is up to date saves money and time and a lot of headaches later on in any kind of work.
Thanks, Chris. And Scott and Robert, I mean, again, the work you're doing, you've been out to Antarctica as well. Do you feel that that's helped you? And even the co-location in Cambridge, you talk an awful lot about the collaboration there.
Yeah, I mean, in terms of, I used to think I was meticulous before I joined the BAS framework in terms of my planning, but this is planning personified. It definitely has opened my eyes up to a whole different world and level of engagement, and engaging with BAS was part of that journey, I would say. Certain things and how they manage logistics, that's a new thing that I've never had to deal with. It's opened up key contacts that I now share with my supply chain. They now come to us, how do you get your stuff to Antarctica? Well, here's a contact for you. So it's sort of touching on what I said earlier on. It's about filtering it down and trying to build it within the wider team that we have. So but yes, absolutely, it's been a real eye-opener, and I don't know about Scott. Scott's been to Rothera a couple of times, but certainly from the BIM perspective, I think this is a step beyond. Or sorry, from the IM perspective.
Yeah.
Thank you, Scott.
Yeah, I've only managed to go once, unfortunately, Robert, and I was there pre-COVID. The times have changed, so when I was there, it was VSAT, very difficult to send email and file. Servers didn't work. We had to be rigorous in our backup and document management and information management, all being stored on servers, having to back that up when they came back. As time progresses, technology improves, we now have internet there. So I'll need to go back and see what that's like. But ultimately, we now have that connection. There's no difference to working in Antarctica now than it is working in Skye or the Orkney Islands, other than I can't go to site and give them a hand. So it does establish a high trust with the staff and the labourers. And I think that's part of the benefit as well of us all working together, as the relationships that we build is second to none between all the partners.
Thank you. And as always, Ellen, I'll leave the last to the client to
very kind. Thank you. I cannot express how much of a difference it makes when you've seen it, when you're talking about different projects and the whole interface at the station, and the fact you've got a runway in the middle and you're trying to deal with all the different operations. You cannot really grasp it without seeing it. I've been fortunate now to do 3 trips to Antarctica and hopefully preparing for another one this coming year. But it has made a huge difference in terms of certainly my understanding when I joined BAS and understanding what the operation actually looks like, but also when we're having these conversations among the partners, that actually we can visualize it, we understand, we've all stood there and thought about how does it all fit together. So I think that's a huge benefit. It is unfortunate that it is so far away, not everyone can go, but hopefully we are able to facilitate some of that as well. We do use things like Mission Room to help people go virtually to Antarctica as well, so hopefully gives people a bit of an insight, but there's nothing better than being able to visit and touch it. It makes a huge difference.
Thank you. So I'll just sum up now as we've got to the end of it. I think all of that, I think it was Robert who put the key principles of polar construction up there. I don't think those key principles are any different from what we should be doing on all our projects. I mean, one of the things for me that I've learned of Antarctica is that pre-planning is everything. The more you put into planning, the less things that go wrong. And that's also, you'll have heard, for data. That's using the data in the right way, making decisions based on evidence rather than supposition. And everybody's talked about extreme distances that they're away, you know, having to work remotely, the weather and that. But all of the things that come out of that, the trust that I think you heard from Scott talking about, are the things that should underpin all of our projects. Project 13, principles of collaboration, of actually understanding not what the client wants, but what the client is trying to achieve, and how you can help them with your skills to achieve that. And I think last of all, the people, and Chris talked about this, is choosing the right people. We should be doing that for all our projects if we can, but it's even more so, as Chris pointed out, when you are stuck in a very small area that you've seen the, it's great, you can actually get it in one picture with the airfield in the middle of it and see the extent of the whole place you'll be living for the next 6 months. So it is important that you get on with people. It is important that you understand what everybody's trying to do. But I think it's a fantastic project. Hopefully everybody here will agree with me. And I'd just like to thank all the speakers for bringing it to life: Ellen, Scott, Chris, Robert, and Bruce. And hopefully you'll all have taken something away. If we haven't answered your questions, that's either because some of them were kind of statements and we passed that on. Some of it was connections on various bits. All that will get passed on to all the members. But as we can't get a clap from everybody, I'll clap for you and say thank you for bringing it to life. And hopefully we'll give the presentations, will be PDF'd and sent round to people, and there will be a recording of this. So thank you all. You've made it really interesting. So there is, just to add, there is feedback. Please do fill out, if you found this a useful one, here you go. It's come up. If you can fill out, it says to rate it. We'd like to do that to see how many more Syria, what type of things you'd like to have in the future. That's the CBD. Upcoming events. You'll see there's a final call for entries on the Build Offsite Innovation Hub Challenge. Those entries will close on Sunday, the 7th of September. Also, what else we got here? On 16th of September, 3 trailblazing finalists will take stage at the Offsite Expos to pitch their breakthrough solutions. And high energy Dragon's Den style final, each competitor will deliver a 10-minute pitch, followed by rapid fire questions from a panel of expert judges. And the information and entry form is available via the QR code you can see there. There's a new approach, collaboration downtime management, and that's looking at the demand for offsite constructions. We've seen lots of category 1 factories go into administration, mainly running through below capacity, poor planning, not enough volume of work going through there. So again, if you can contribute to the survey there to shape the future of offsite manufacturing. Government is very keen on the use of offsite in various areas. So again, use the QR code there. And then here is the, it's time to put water at the front, it says here, at the RHS Chelsea Flower Show. Build Offsite is proud to support the concepts of a Suds Garden. Gosh, that's something I've learned there about the Sud. I didn't even know we had a Suds Garden. And Future Water. The garden's more about athletics. Please register your interest by following another QR code on here for that. And that, I think, brings us to the end of the presentation. So thank you all for staying to the end. Thank you all for your questions. Again, thank all the speakers for their great contribution. And I look forward to seeing all of you probably again in the future. Ellen probably in Cambridge before Rothera. So bye for now.